First question. The correct order of second ionization potential of carbon, nitrogen, oxygen and fluorine is. So ionization potential increases across the period. That is, it should go like carbon, then nitrogen, then oxygen and then fluorine. But the second ionization potential of oxygen is highest among them, because after the removal of one electron, the second electron is to be removed from half-filled orbital, which is difficult. That means oxygen has, after removal of one electron, oxygen attains a stable configuration. And to disturb that configuration, we require very high amount of energy, more than that of a fluorine. So now the correct sequence would be carbon, nitrogen, fluorine and then oxygen. Now looking at the option for this, carbon, nitrogen, fluorine and oxygen. So the correct answer is option C, that it goes like highest for oxygen, then fluorine, then nitrogen and then carbon. Moving towards the next question. In a period, elements are arranged in strict sequence of. So in a period, atomic number increases with increase in number of protons and electrons. Thus, elements are arranged with increasing charges in the nucleus. So among the given option, the correct answer is option B, that is increasing charge in the nucleus. By decreasing the charge in the nucleus, the elements cannot be arranged. Constant charge in the nucleus, it's not possible, and also the equal charge in the nucleus is also not possible. So the correct answer is option B, that's increasing charges in the nucleus. Next question. Which of the following have high electron affinity? Now first of all, electron affinity. It is the amount of energy released when an electron is added into a gaseous atom. Electron affinity decreases down the group, but electron affinity of some elements of second period like nitrogen, oxygen and fluorine are however lower than the corresponding elements of the third period like phosphorus, sulfur and chlorine. This is due to the reason that the elements in the second period have the smallest atomic size among the elements in the respective group. As a result, there are considerable electron-electron repulsion within the atom itself, and hence the additional electron is not accepted with the same ease as is the case with the remaining elements in the same group. So the correct answer among the given option which have the highest electron affinity is the chlorine, because they would have the lower one. So correct answer is option B. Moving towards the next question. In which of the following arrangement the order is not according to the property indicated against it? Now if we look at this, aluminium plus 3, magnesium plus 3, Na plus and F minus, increasing ionic size. So it's a correct one that anion will have the bigger size and the cation will have the lower size. We have to find which is not according to the property indicated. If you look at option B, boron, carbon, nitrogen, oxygen, and this is the increasing first ionization enthalpy. Ionization enthalpy is the amount of energy required to remove the loosely bound electron from an atom in gaseous state. Ionization enthalpy increases from left to right in a period, but it is not correct. The correct sequence is boron, carbon, then oxygen, and then nitrogen. It's because nitrogen has more stable configuration than that of oxygen. So the correct answer is option B. If you want to look further, so this arrangement is the increasing electron gain enthalpy and this is increasing metallic radius. So it's down the group property, lithium, sodium, potassium, rubidium. So down the group definitely metallic radius will going to increase and electron gain enthalpy. So it will also increase in this pattern only. So the option which is wrongly arranged is option B. And the last question, fluorine, chlorine, bromine, and iodine are placed in the same group 17 of the periodic table because the reasons are they are non-metals. So it's not that reason because there are other elements also which are non-metals. So the reason why fluorine, chlorine, bromine, and iodine are placed in the same group, group 17, is not this. Looking at option B, they are electronegative. So there are very different elements who are also electronegative, but they have placed in a different groups. Now, option C, their atoms are generally univalent. So that is also not the correct reason why the elements are placed in the 17 group or a same group. Option D is the correct one because the reason is they have 7 electrons. That is the configuration Ns2 Np5. Halogens, this group 17, they have 7 electrons in their outermost shell and have the configuration Ns2Np5. So the correct reason why the fluorine, chlorine, bromine and iodine are placed in the same group 17 is they have 7 electrons in the outermost shell of their atom.